All right, we are looking at FRQ number 3A. This is AP Prep number 7. And they give you this Maclaurin series here for ln of 1 plus x, okay? And they want us to find the function for f, which is ln of 1 plus x cubed. So you'll notice they took out the input of x and they put it in x cubed. So that is exactly the same thing that I need to do here. So the original series is, you had x in the first position. I'm going to have an x cubed in the first position. The next term was minus the input squared over 2. I'm going to put an x cubed in place of that. Then it was plus the input cubed over 3, and I'm going to put an x cubed in for that. And then it was minus the input to the 4th over 4, and I'm going to sub in an x cubed for that. And so you can leave it like that, actually. You don't have to simplify, but for some of these problems, the simplified version is better to use and sometimes not. So I'm going to go ahead and that's x cubed minus x to the 6th over 2 plus x to the 9th over 3, and then that's going to be minus x to the 12th over 4, okay? General term there, you can kind of look at the pattern. Remember, the original general term was x to the n over n, so you can actually just substitute an x cubed in for that. It's going to be x cubed to the n, which, by the way, a power to a power, you multiply, so it'll be x to the 3n all over n. So again, you could just put an x cubed in this statement here, or you can just kind of look at your simplified one and try to figure out what's going on. But that's the basic idea there, okay? And by the way, they're starting out with their n. Their first term n is equal to 1 as opposed to 0 here, if you look at the way they set their statement up. So I don't think it's the worst thing in the world just to note that. All right, we're going to take a look at part B here, radius of convergence. If you recognize the natural log series there, it is actually centered at 0. And if you knew that, you're really just going forward 1 and backwards 1. However, if you don't recognize that, they don't tell you to use the ratio test here, but the ratio test would normally be the way you would do that. So the ratio test, remember, you want to take the limit as n approaches infinity of the n plus 1 term divided by the nth term. We're actually looking at the absolute value of that. We want that absolute value of that limit to be less than 1, okay, if this is going to be convergent, okay? So I'm going to take the limit as n approaches infinity here. And we've got negative 1 to the n plus 2. It would be x to the n plus 1 over n plus 1. And you're going to divide by the nth term. Dividing is the same thing as multiplying by the reciprocal. So I'm going to go ahead and just do it like that. And, oh, I lost my negative 1 to the n power there. Okay, the negative 1s really aren't going to affect anything here, that absolute value. You're technically going to be left with, well, 2 of these will, n negative 1s will cancel. You'll have 2 negative 1s left, but that becomes 1, okay? Anyway, if you simplify here a little bit, you've actually got x to the n plus 1 over x to the n, and then you've got an n over an n plus 1. And you're looking at the limit of this as n approaches infinity. Well, all of these n's are going to cancel all but one, all of these x's are going to cancel all but one of those x's, okay? So we're just left with x here. The limit of this as n approaches infinity is going to be 1, right? Because you've got an infinity over an infinity plus 1. And so as a result, we really just have x, the absolute value of x we'd like to be less than 1. If I want to get rid of the absolute value, it means that x has to be between negative 1 and positive 1. Okay, so that actually would tell us that 0 is our center, and we're going up 1 and back 1, and that's our radius of interval of convergence being 1. Anyway, what we need to do here is check the endpoints. Because the ratio test only speaks to values that work out to be less than 1. We have to check 1 and negative 1 and see if those series converge or diverge. So if you put negative 1 into the series, if you put negative 1 into the series, negative 1 cubed is negative 1. Negative 1 to the 6th times negative 1 will be negative 1/2. you're going to get negative 1/3, negative 1/4, and so on. If you notice, that's the harmonic multiplied by negative 1. Okay, that's negative 1 times, that's negative 1 times 1 plus a half plus a third, and so on. That's a divergent harmonic series. Okay, if you sub an endpoint of 1 into the series, you're going to end up getting, where's my series up there? Let's see, if I sub 1 in, I'm going to get 1 minus a half plus a third minus a fourth, and so on. That is an alternating harmonic that converges. Okay, so it can equal 1, it can't equal negative 1, and that is the full interval of convergence. All right, now we're looking at 3C. This is right, the first 4 non-zero terms of the series for f prime of t squared. Now, I was thinking that they had taken the derivative of function f with t squared subbed in. However, if you applied the chain rule there, that would have been 2t times f prime of t squared, multiplied by the derivative of the inside function. So if you think about it here, they're just saying take the derivative of function f, which we already have from the earlier part, and substitute in t squared. Okay, and then there's a second part there. We'll deal with that in a second. All right, so here's function f. So the derivative is going to be 3x squared minus, it would be 6 over 2, which is 3, x to the 5th, plus you'd have 9, but 9 divided by 3 is 3, x to the 8th, and then you would have minus, let's see, 12 over 4 is also 3, x to the 11th. Okay, so that would be f prime of x. So f prime of t squared, we'd sub a t squared in there. So t squared squared would be 3t to the 4th. T squared to the 5th would be minus 3t to the 10th. T squared to the 8th would be plus 3t to the 16th. And then t squared there, that'd be minus 3t to the 22nd power. Looks like it would be f prime of... Okay, this next part they want us to find g, which is the integral of f prime of t squared. Well, we now have f prime of t squared, okay? So one of the great things about the series is you take integrals like you normally take integrals. So we're going to just take the integral of this whole thing, and it'll continue out past that 4th term, but we should be able to get a pattern. So raise the power by 1, divide by the new power. Let's see, the integral is going to end up being, that'll be 3/5 t to the 5th minus 3/11 t to the 11th plus 3/17 t to the 17th minus 3/23 t to the 23rd. Okay, and of course it continues out infinitely. We're going to evaluate it between 0 and x. Okay, so if we substitute x in here, we've got 3/5 x to the 5th minus 3/11 x to the 11th plus 3/17 x to the 17th minus 3/23 x to the 23rd. And again, that continues on infinitely. We want to subtract, it's fundamental theorem, right? So we got to sub in the x and we got to sub in the 0. We want to subtract this whole thing evaluated to 0. Well, if I sub in 0 for each of these values, that's all going to become 0. So it's really just going to be this 3/5 x to the 5th minus 3/11 x to the 11th plus 3/17 x to the 17th minus 3/23 x to the 23rd. Let's see, and they want the first 2 non-zero terms. Oh, I've gone way too far. I want to approximate g of 1. Okay, so g of 1 approximated with the first 2 terms. That'd be 3/5 minus 3/11, and you don't really need to simplify it. You could leave it like that, but anyway, that'd be 33/55 minus 15/55. And let's see, 33, that's 23, is that 18/55 possibly? But again, you don't have to simplify it. You can just leave it in that form on the FRQ, and that's totally okay. Let's briefly talk about part D here. So we estimated that value of g of 1, And of course, we only used two terms. We didn't go out infinitely far. And the question is, how far off is that error? And this is an alternating series. So remember, alternating series error is never going to be any greater than the first omitted term, technically the absolute value of the first omitted term. So if you go back here and look, the first term that we omitted was the 3/17 x to the 17th value. So for the error there, we can just evaluate that at 1, and that's just going to be 3/17, okay? 3/17 is less than a fifth. And so anyway, we've shown there that the error is in fact going to be less than 1/5. So we didn't do that in 2020, but in other years that is something that could come up.